Welcome to one and all. Today I am explaining about the model analysis for a stable bar. My name is KVJ Kumar. Introduction to model analysis. Model analysis is a technique used to determine the natural frequencies and mode shapes of a structure. It helps in understanding how structures respond to dynamic loads. The analysis is essential for predicting potential resonance and ensuring structural integrity. Overview of a stepped bar. A stepped bar consists of multiple sections with varying cross-sectional areas or properties. It is a common structural element in engineering applications. The variation in geometry influences dynamic behavior significantly. Importance of model analysis for a stepped bar. Model analysis helps identify critical frequencies that could lead to resonance. It aids in designing to bar and avoid failure due to vibrational stresses. Understanding mode shapes provides insight into how the structure deforms during vibration. Types of vibration modes. The primary modes are bending, torsional, and axial vibrations. Each mode has distinct characteristics and frequencies. The analysis involves identifying these modes for a comprehensive understanding. Assumptions in model analysis. The material of the bar is assumed to homogeneous, assume linear elastic behavior. Damping is typically neglected or modeled separately in initial analysis. Governing equations for a step bar. The axial vibration of a bar is governed by the wave equation considering varying the cross bisections. Boundary conditions depends on whether ends are fixed free or supported. The differential equations are solved piecewise for each section of the stepped bar. One is statistic stress analysis of a stepped bar. Example D1 is equal to 55 meters, D1 equal to 27.5 mm, E1 is equal to 70 EA, E1 equal to 200 in EPA, Poisson ratio equal to 0.3. Analytical methods overview. The transverse of a matrix method is commonly used to analyze stepped bars. Rayleigh's equation can estimate natural frequencies. The eigenvalue problem for formational is central to model analysis. Transfer matrix method in detail. The transfer matrix relates the state variables across each section of the bar. It simplifies solving for multiple sections with different properties. By multiplying matrices, the entire structure's dynamic response can be analyzed. It is used to the solving for multiples of the properties and the variables and things. By multiplying materials, entire structures, the transfer matrix relates the states variables across each two section of the bar. Boundary conditions and compatibility. Boundary conditions are applied to ends of the bar, such as fixed or free supports. Compatibility conditions ensure displacement and slope continuity at the interfaces. These conditions lead to system of equations to solve for natural frequencies. Boundary conditions are ensure the displacement to the slope continuity of the interface to solve of the natural frequencies. Numerical techniques for model analysis. Finite elements methods. FEM express stepped bar into elements for analysis. The eigenvalues problems is solved numerically to find natural frequencies. Software tools like ANSYS or Abacus or Ma- MATLAB are often used for this purpose. Mode shape visualization. Mode shape visualization illustrates the deformation of pattern at each natural frequency. Visualizations help in understanding potential failure points. They are crucial for designing structures to avoid resonance. Mode shapes illustrates the deformation pattern at each natural frequency to the failure points and the resonance to the designing structures for crucial roles. Effect of step changes on frequencies. Variations in cross-sectional areas cause shift in natural frequencies. Larger steps generally lead to lower uh, frequencies due to increased the flexibility. Accurate modeling of step geometry is essential for precise analysis. Partial applications of model analysis. Model analysis is used to design of beams, shaft, and structural components. It helps in minimizing vibrations in machinery and structural systems. The technique is integral to predictive maintenance and structural health monitoring. Experimental model analysis. Experimental methods involves executing the techniques like impact testing and shaker testing are common. Results validate numerical models or improve design accuracy. Experimental methods are to the data potential and like impact to the testing and shaker methods are common. Challenges in model analysis of step device, complex geometries and boundary conditions analysis. The damping effects are often difficult to model accurately. High computational demands may arise for detailed models due to the light of effects and the challenges in model analysis to the step bar and play a crucial role in the geometries and boundaries of the conditions to the complicate analysis. Case study example: a stepped aluminum bar was analyzed to result shown significant shift due to stepped change in a cross section. The analysis guided modifications to improve vibrational performances. A stepped bar was analyzed due to the determine and utility natural frequencies to the both and cross section in the vibrational performance to the improve and analysis guide information. Design consideration. Proper selection of material and geometry affect vibrational characteristics. It always uses the it is not properly used to the machine to the vibrations of the characteristics. Support conditions and should be chosen to minimize adverse vibrations. Regular model analysis help in maintaining structural safety over time. Feature tense in model analysis. Integration of advanced computational methods enhances accuracy. Use of smart sensors enables real-time model monitoring. AI and machine learning are being explored for predictive model analysis to the enhances accuracy to the smart real-time model monitoring. Summary of the key points. Model analysis provides critical role into the vibrational behavior of methods, components, and experimental techniques. Proper understanding and application prevents structural failures and optimize designs to the crucial and the critical insights to the vibration of people to the enhances vibrational structural failures and optimize designs. Thank you.